Hi, can you hear me on the back? Hi, I'm Marco. I'm Marco Gaboardi. I'm very happy to be here. I thank the organizer for inviting me here. And when they invited me, I hesitated whether to give a technical talk or a less technical talk. I'm not sure this can be even classified as a skill talk, but it's a bit my experience in collaboration. And that's why I came up with this idea of talking as a research as a collaborative effort. So most of my work has been in collaboration, and I think I want to share with you some of my experience. But first, I would like to go into two different aspects of collaboration. So first, collaboration for the community. So collaboration is about building things together, and we are a research community who is trying to solve some problem together. Let me take an example to make this more concrete. So a huge amount of work has been going into developing certified compiler in the PL community. So what was the problem here, or what is the problem? By the way, I tried to take a problem that introduce you to the next talk, where we will hear more technical things about this. But for my talk is a more high-level perspective on this. So just to see how our community has contributed to this goal. So what is the problem here? The problem is to build a compiler and a mechanized proof showing that the compiled code behaves similarly to the high-level code. It's an intuitive problem, and indeed it was already formulated in the 60s in the paper by McCarthy and Painter, where they look at the compiler correctness for a simple arithmetical expression language. And shortly after, it was also mechanized through a mechanized logic and proved correct. Now, after this work, of course, there has been a lot of other works, and the community has really put effort in trying to verify more and more complex compiler. And this has generated a bunch of ideas and a bunch of techniques on which people have focused. People have focused on translation validation, on developing better proof assistance, on study simulation relation that can be non-trivial when we have parallelism and concurrency, on testing suite for compiler correctness. And then in 2008, the work by Xavier and Sandrine and their group brought us the CompCert verified compiler, which I think it was a milestone in certified compiler. And they show that we can really, with the technique that the community has built, we can verify realistic compiler. And of course, this was not the end of the story, but was the beginning of another story, because then people have focused on other issues with compiler correctness, like optimization, security, side channel, the use of resource, and so on. I think this is a successful story for our community, but what was the real goal beyond this effort? What were they trying really to achieve? Why did they focus on compiler correctness? Why all these people spent a large part of their life proving compiler correctness? Any idea? Yes? Easier, safer programs. Yes, I think that a word that can summarize is correctness. Make sure that our programs are correct. And what motivates correctness? I don't know. My perspective on correctness is that if we have bugs in program, we can create harm. So we can harm people. We can harm people in several ways. We can harm people because our software maybe cause accident. We can harm people because our software maybe create economic crisis. We can harm people in several different ways. And when I was at about your age, I was an idealistic person. I think I'm still are. And I was looking for spending my time on something that has an impact beyond my actual work, trying to influence a bit society with my effort. And I think this view on correctness is what motivated me in developing my technique, in spending my time developing technique for correctness. And I think this is something that many people in the community share. They believe that by making software more secure, less error prone, we can improve really the life of people. So I was idealistic, and I still am, but at some point I stumbled into this question that made me think a bit more about what I just said to you. This is a question by Tanimoto, who is a professor at UW. And mainly is asking us, as a programming language designer or programming language technique designer, can we also create ARM? So I was motivated by the good, but I was not seeing that indeed we can create also some ARM, and we should think about it. Do you have any idea on how we can create ARM by programming language design? Yes. Yes. So there is the negation of what I was saying before, like creating more bugs. There is some technical question, but a bit more high level. Any idea? Yes?
I think maybe in the pursuit of higher levels of complexity, you may forego accessibility.
Yeah, that's a very good point. And indeed is one of the points that Tanimoto makes. So is the way we design languages a way to create barriers or to overcome barriers? So when we do our technical work, are we thinking about this question? Is literacy in programming something valuable that we are building like literacy in the real world languages? Is the programming language technique that we are developing playing a role in the ethical or unethical use of technology? So I think these are questions that us as a community that is collaborating over a problem or over trying to solve problems should think about. And more in general, I think that the question that we should think about is, can more good be done by designing a programming language technique? So society is facing many challenges. We hear these all over the news all the time, like climate change, social inequality, access to resources, discrimination, and so on. Can we do something for those problems by designing programming language technique? Do you have in mind any example? I can give you a few. Yeah, that's an example. Here another example. There are people working on technique to make our software more fair and avoid discrimination. There is a good group at University of Wisconsin working on this, trying to use program analysis to avoid that our algorithm make discrimination and our software make discrimination. There are other groups that are trying to develop programming languages that allow us to design more green software, for what this means. So trying to save energy and try to be more green. I think it is important that we keep in mind that what we do has an impact on the world. We are community which is collaborating to try to solve a problem, maybe we should try to address some of the challenges that our world is facing. So, but I think I talked enough about blue sky. Let's be a bit more concrete, because this is only one aspect of collaboration, is the community aspect of collaboration. But I think you are here as individual, and you want, as I did, also to understand what is my role in this, how I can collaborate with other people to try to solve some of this problem, and especially try to focus a bit on what we can do as individuals. Now, if you are not motivated by this societal problem, here another motivation why you should care about collaboration. So here is the statistics of this year acceptance at POPL. And on the x-axis, you have the number of authors for paper, and on the y-axis, how many papers have this number of authors. As you can see, it's very unlikely. There will be few of you maybe that will work on their own, but it's very unlikely for how research is designed today that you will work just on your own. It's more likely that you will work with a collaborator, or maybe two, or maybe three, or maybe more. So for the rest of my talk, I would like to go a bit more into concrete advices on how to collaborate, or what to do to better collaborate with other people. So more the individual dimension. So let's start. I will try to give you 10 advices, and let me start from how to start to collaborate. So my first advice is to start to collaborate from your advisor. So is learn from your advisor. I was lucky enough to have two advisors. You can see here them in the picture, because I had a PhD in Italy and in France. So I had an Italian advisor, Simona Ronchi della Rocca, and a French advisor, Jean-Yves Marion. And I learned a lot from them. I learned the method of doing research, because I was coming to the PhD with a very rough idea of what doing research is. I thought it was just sitting in a room, doing my work, and then publish my work, and go on like this. And then I discovered that this is only a very small fraction of the job. So I learned a method, but I also learned the passion. My two advisors were very passionate about their work, and I learned this passion, and I think I'm trying to transmit my passion also to my students. But the most important thing, I think, that I realized only after many years, is that what I really learned was to master a technique in the technical sense. So I did my PhD on type system, especially type system related to linear logic, inspired by a very semantic interpretation of functional languages, and the use of this type system for complexity. And I think I learned a very solid background on how type system allow us to analyze program. And then I use this technique in all the rest of my research in the following years. So try to learn really from your advisor, not really just about your specific problem, but a technique, because this is what you will use in the future. It's like the hammer you will have in the future for your problem. My second advice is about paper. Read paper. Now paper are very easy to access. When I started, I still had to go in the library and copy them. You have them all available, so try to read them. Why? Because this will help you to find out who is working on similar topic, who can have answer you may need in your work, and who may need an answer you have. Maybe you find out that the hammer you just developed has other application, and so you will have the opportunity to produce new piece of science. Now, on this, there is always a good balance to find, because if you spend only time reading paper, you will not produce anything. If you only try to produce things, you will reinvent the wheel. Okay? So you need to find your balance. And of course, all the paper don't need to be read from front to back. You can just maybe skim them. But it's important to know who are the other people working on your field, working on your problem. This is the key, I think, to collaboration, because if you know who is working on a similar idea, you can go and talk with them and say, I have this. And this is indeed bringing me to the third advice, which is take action. Don't expect other people to come search for you. It doesn't mean that it's not a matter of importance. It's not because you are at the beginning and maybe you didn't have a result yet. It's more about making a connection. And often other people don't know how to make a connection towards you. So try to go the other way around. Try to make yourself the connection. So don't expect that they will come for you, but go for them. And especially get out of your comfort zone, because we all are a bit, I think, shy to go talk with other people, especially more established people. I still remember the first time I talked with Xavier, and I was very shy, and I think I even said a lot of stupid things. But here I am, still alive. It didn't made anything against me, so and here this brings me to the next advice, which is I think we are very lucky as in programming languages, because we have a very good community. This is not true of all the research areas. I think we have a very good community that is supportive. I think this mentoring workshop is a proof of that. You are here supported by the community to see if you want to be part, or because you just started to be part of this community. And I think we are very lucky. And again, by using the community, we can learn what other people do, and we can start a new collaboration. You are here, go around, see what other people do, and try to talk with them and start to collaborate with them. And especially when you talk with them, try also to listen, because often it's not only about talking, it's about listening. Try to listen what are the problems that excite other people, because that will give you ideas for your future research. And the conferences we have some great conferences like POPL, PLDI, ICFP, UPSLA, and many other. We have a society like SIGPLAN and SIGLOG that can support us. SIGPLAN is supporting the mentoring workshop. And we also have a summer school that where you can learn new things, meet other people, meet other students that have similar questions. Actually, because I'm shameless, here I will do an advertisement. So I involved this year, last year, and another time, I've been involved with the Oregon Programming Language Summer School, which is a great place to meet other people, to learn about other areas of research. That's where I talked the first time with Xavier. And I think it's a great place to be. So this year, data, so unfortunately this year we are a bit delayed in gathering the information, but this year's school will be between June 29 and July 11. We will also have a boot camp on June 21st, between June 21st and June 27, where we will focus a bit on the basis that you will need for the rest of the school. You can have more information about the school as this website, but it's not updated yet. Hopefully we will update it in the next few days. And you will get also a t-shirt. All right. So we talk about how to start to collaborate, but what about when we have established some collaboration? So my next advice is share your idea. We heard already from Lindsay how sharing ideas is important, maybe also when you are early in the development of your result. Try to share as much as possible. I believe in open science, where we share our ideas, because remember, if you take a bit the perspective I gave you in the first part of my talk, if the goal is really solving some problem, some bigger problem, why do you need to keep your ideas for yourself? You're not really contributing. Of course, it's again a difficult balance, because we want ideas to also give us back something, maybe a paper, maybe a PhD thesis. So it's important to also work on your idea. But I think the thing that is important to realize is that you are more than one idea. You will, if you want to do research, you will need to develop more ideas, not only one. Nobody have a career on one idea. So don't be attached too much to one single idea, and instead try to focus on having many different ideas. The next advice is once you have a nice collaborator, like I have had a good collaborator that is sitting here on the first row, try to learn from them. Try again, like I said before, for your advice, or try to learn also from your collaborator. So I met Justin when he just arrived at UPenn as a student, as a PhD student, and I was there as a postdoc, and we started working together because he took a class on a topic that I was also starting to work on, and then we started to collaborate from there. And we had a lot of collaboration together. We wrote many papers together, and I think I learned a lot from Justin. So one thing I learned is how to travel to a conference with only a backpack. This is a very important skill. More seriously, I learned a lot from Justin. I learned how to look at problem in a different way. He has a very different angle from the one I had, and I try to use his perspective now in everyday research. I learned also technical ideas from him, like we have been working on some probabilistic program and how to interpret this probabilistic program in a relational way using some tool from probabilities. And I was not aware of this technique. He was the one making me aware of this. So I think I learned really, and as Justin, and many other. I see some other of my collaborators in the room, and I learn also from them. I tried really to think all the time that a collaboration is an occasion also to develop myself and to learn, because that's what we are here for, is also building ourselves. So try to learn as much as possible, technique, problem, passion, and anything you can learn, even how to pack a backpack. The next advice, I hesitate in putting it into my presentation, because I'm sure you are more skilled than me with technology. So there is not much that I can tell you here. I'm sure you have, you grew up with technology much more than I did. But I think it's important to use this technology for collaboration. And I think is often something we forget, but we should take a scientific approach to how to collaborate, try to make it effective. And for this, we have several tools. We have tools for video conferencing that help us being in touch with people that are far away. We have many other collaborative tools. When I started doing research, and by the way, I'm not so old, I'm just 40. So it's not that I'm talking about 1910, I'm talking about year, I started my PhD in 2004. So for some of you is the middle age, but it's not so back in time. But when I started, it was a very uncommon to have a conference call. Like I was doing all my research with people at my institution. Then after a few years, I started to do few conference call and do work with people at other institutions. Now I spend half of my week on a conference call. So try to use the technology in a way that is the good one for yourself and that meet your need for collaboration. And especially try to use technology to make collaboration a natural process for your everyday life. Talking with people that maybe are around the globe can seem difficult, like often I have a collaborator in Japan, I have a collaborator in Europe, I am in the US, and it's difficult to find time zone. Luckily, my collaborator in Japan like to go to bed quite late, so we can talk when it is late for him. But try to make it a natural everyday process where you try to talk with your collaborator every week and maybe even multiple times a week if you are under a deadline, and try to get as much as possible. Now, I want to do another intermezzo where technology can be useful. So I said before that we sometimes should think about the problem that society has, and we should try to solve them. We should also try not to make them worse. And traveling, as we all know, can make the situation worse. So traveling for collaboration is an important part, because I think to start a collaboration, maybe talking with people in person is better than just, and we don't have a way really to start a collaboration just online often. It's not always the case, but often we don't have this occasion. So attending conferences is still important. I think you are here at this meeting, and it is important to be here in person. Maybe this will change, but it's important to try to use technology as much as possible to avoid create other problems. So maybe we will have a further solution down the line. Now, this is probably one of the most important advice, and maybe it seems trivial, but is often difficult, is often easy to forget, and is don't forget about yourself. So when you are collaborating, try always to understand what are your strengths. So what you bring to a project is not only your time of working, but is your strength. You really need to engage in project, in collaboration, where your unique strength play a role. Because each one of us is unique. Everyone has a different strength, and we need to put this strength to work to solve a problem. At the same time, you should try to keep yourself excited about the research. So if you are not excited about a project, change the project. If you are not finding what excites you, talk with other people and try to understand it. And try to find overall a good balance between yourself and the other people. Try to find a way of working that contribute to bigger goal in collaboration with others, but still make you satisfied. This, I think, is very important. Okay, so still 2 advice to go. And the next one are about going a step further, going to collaborate with people from other fields. So why I decided to introduce this? Because I think we are at this particular historical moment to solve some of the problems that we are facing. We really need to collaborate with other people. I'm sure again that you have already seen this in your experience. You know how collaborating across different areas of research can help solve a bigger problem. And so I think it's important to think about this as well. So in this direction, I think it's important to expand our interest. Try to find other things that excite you. I'm sure that there are tons of things that excite all of you. It's just sometimes maybe you don't think about them in terms of work. You think in terms of other dimension of your life. But I think if you can find what else excites you, you can go talk with people that are working on this and feeling excited as well. Of course, this you need also to think what would be a good application for your research. And also, you need to understand technically what you can do for other people. And this can be rewarding. So let me tell you about my experience. So when I met Justin, I was coming, as I said before, from type theory world. And both of us discovered this thing that is called privacy. I'm sure you have heard about it. So privacy is a complex problem because it's a problem that is not only technical, it's also a problem that is legal. You need a policy and law to talk about privacy. You need the technical support to solve a privacy problem. It's also a problem about perception, so it's also a behavioral problem, how people react to having their privacy violated. So for this reason, I started to work on privacy from the technical perspective, and then I got more and more interested into the global question of privacy. And I have been collaborating with people from other areas, for instance, with people from law and policy. And this was very rewarding because I learned things that I would have never expected to learn, like how policy are designed, what policies say. In particular, I have been working on some policy for privacy in the educational sector, and this was very useful for me. The other side of the coin is when you talk with people from other areas, especially I can guarantee when you talk with people from law and policy, you need to be patient because you have a very different understanding of the problem. Very, very different. You cannot expect them to understand the problem in a technical sense if you don't give them the problem step by step. On the other hand, you will be in the same situation because I was not understand anything about policies the first time we started to talk. I was saying, why cannot they just enforce these instead of being so unclear on when to apply a policy? And then I understood the formamentis that law and policy scholar have. So I think it's a rewarding experience, but you need to make some step out there. All right, this concludes my 10 advice, so let me try to wrap up. So I think collaboration is an important topic because it has these 2 dimensions that I tried to give you. One is building something together to try to solve some bigger problem, and the other how to relate this to ourselves, how we can collaborate with other people more concretely. Now, if you didn't buy all my talk, there is one last reason why you may want to collaborate. So, as I said before, we have passion. So my passion is hiking. I like to go hiking all the time. And having many collaborators allow me to go hiking more. So I was able to bring all my collaborators to some good hikes. So this is a way to say that your collaborator may become also people with whom you share something beyond your work, and that collaboration is fun. And with this, I conclude.
Thank you for the talk. So we have time for some questions. Anybody from the audience?
Thank you for the great talk. I believe I am passionate about my research, but a lot of times I feel that my advisor's passion for research is on another level. And it was interesting to me that you learned passion from others. Could you elaborate on that process more, maybe sharing your own experiences?
Yes. So I have been collaborating with many people that are not only my advisor. And when you start, of course, I didn't start from the passion aspect because I started from a more technical perspective. I had a problem and I needed maybe technique that I didn't have. Or the other way around, I had a technique and I wanted a problem. So this is usually the way I started collaborating. Or maybe we were having a coffee and we came up with an idea. But after that, you are put in touch with other people and other way of doing research. And often, at least in my experience, these people are passionate about what they do. Of course, this is not a universal law. There are people that maybe have a different perspective, but I was lucky and I found always people that were very passionate about it. And at the point, sometime to really get almost obsessed by our work and our problem, and we share I think you can see this by the way one approached the problem and the way one approached the solution. So it is not uncommon for me to spend even weekends to work with my collaborator because maybe we come from different areas. Like, as I said, I have collaborator from Japan and maybe they come to visit me for 2 weeks. So we really want to use every minute we have for working on our problem, and in this I see their passion about research. So I don't know if this this answer your question, but I'm happy to talk more later.
Okay, we can have at least one more question. In the meantime, could the next speaker set up? Anybody?
Hi, thanks for the talk. It was very insightful. So you mentioned we should be reading more papers and whatnot. My question is on the sense of, do you have advices on how to find interesting papers for you to read so that you can maximize your time? Because it can feel a little bit overwhelming to go, for example, through all the conferences that are happening every year and finding everything that's slightly related to what you're doing, and sometimes they're way much more technical than stuff that we are doing. Like, I'm still just for a first year. I don't have that level of insight.
It's easy to get overwhelmed.
Yeah.
I definitely agree. So let me ask you a question. What is one thing that excites you? Just the first thing that comes to your mind.
Proving theorems.
Proving theorems. Great. So then you can talk with Xavier. This is a good way to start. But maybe you should try to identify what are the main papers in this area. Of course, there are tons of paper. As I said before, it's difficult to find a good balance. It's important to read about foundational work, but this will not give us a paper because if they are about foundational work, probably have already solved a foundational problem and we will not solve it. So starting from there, then you need to backtrace to more recent paper and what are the papers that are doing some good contribution and what these contribution are and what is a problem that is not solved yet by this paper. So I understand there is not really a magical recipe here, but I think being aware of who is doing what is the first thing to start. And as I said, maybe what some people misunderstand is that when I say read paper, they think about reading paper from the front to the back, try to understand all the technicalities, maybe also going into proof. That's not what I mean. Just try to understand the general idea and work from there. Okay?
Okay, thank you very much, Marco, for